Hello, dear viewers. My name is Nikita, and I'm glad to welcome you here. And I'm pleased to introduce Roberto Freato, an independent IT consultant from Vitaler. Hello, Roberto.
Hi, Nikita. It's a pleasure to be here with you and the attendees.
Oh, me the same. Cool. Roberto, as I understand, you have really something special for us because relational concepts is something basic for many of us, almost sacred. And are you going to change our mind through the JSON?
Yeah, maybe. Don't really change. I want just to share my point of view, my experience, what I learned in the last 2 years. I think so. I hope it would be interesting for you and for the audience. Yeah.
I also think it will be useful and interesting. Sure. Dear viewers, let me remind that you can ask questions in the chat. It's better to do it right along the way. Don't forget them. We will try to answer during the presentation for some of the answers, but also you're welcome to the discussion zone in the Zoom after the presentation. There we can finish and discuss all other questions. So, Roberto, I think we can start. What do you think?
Yeah, let's go. Absolutely. Cool. Okay. So, thanks to be here. What I want to discuss today with you is how, as a developer, because I've been a developer for my entire life, how I found it really interesting to mix the relational database usage with something that is not really relational in terms of reception, so JSON documents. Okay, so I start from some assumptions. Okay, I don't want to give the message that this is a contest between the relational approach and the NoSQL approach. I really use and I've used for a lot of time relational database and tables. So I think the relational database is here to stay and it's here to evolve during time. But I also think that NoSQL is awesome for many reasons. I've been until 3 years ago, I've been in an e-commerce company where we discovered how elastic a search and a similar product in Azure called Azure Search was really awesome for a specific situation and a specific purpose of searching documents, okay, for the search bar of the e-commerce that we implemented. So we mixed the relational approach that we already used for the orders management, the orders collection, the logistics, the details, the catalog, okay, with the NoSQL alternative to build a good and a powerful search engine around e-commerce. Okay, so that probably it's about 8 years ago, something like that, started to change my mind into a single approach to the persistence. So I passed some years to hear about polyglot persistence, the way to have microservices with their own persistence implementation. So one service that goes through MySQL database, another one that is going to MongoDB, and another one that is going to relational. Of course, not just to be funny and cool, okay? But if you have a real scope tied to MongoDB and you want to use that because you have good skills on that and the project is really fitting that case, I'm really a fan to mix all this technology in a proper way. So these assumptions are just to tell you that it's not something to say, okay, the JSON into the database is the best solution, the database itself it is, the NoSQL itself it is. No, I just want to share that the integration between that points, that technologies, I think it's the key to unlock the potential of your solution, of your software solution. Well, I want to introduce a common scenario that you probably know when you deal with a data platform, with a data solution. Okay, I'm working with data for some years, especially in the last 2 or 3 years, and I discover a common pattern between different projects in data integration. For instance, do you have some data outside your company, and those data can be an API integration or flat files that are just dropped into an FTP, a plain old FTP. Can be something like border databases when you need to pull the data and push the outbound data. So there are many ways, technically speaking, in which you can exchange data without the outside world, okay? But they have some special things in common. For instance, when you take from outside that data, you should often clean it. So clean the rows that are wrong, fill some holes, filter in case there is some inconsistency into the data set that you are taking. And when you clean the data, you will probably want to create the structures in the relational database that will hold the data, okay? The data set. So for instance, if I have the list of geographical cities all around the world, I would create a table that will hold the cities, probably another table that will hold the regions, the countries. I would establish the foreign keys. So I will engineer the database to map the data that is coming from outside, okay? After that, I would need probably to set up something to ingest that data, so to collect the data from outside, transform it, and put into the database table that I've created, to finally produce the data. What I mean with production, okay, when I'm collecting in my experience data from different sources, that data comes in a raw way, okay, in a natural way. And after the cleaning process, the engineering part, and the ingestion part, the final shape of that data was really different. For instance, a single incoming dataset should become 3 different tables, but this is a design choice. So this is something that us as database engineers want to establish in the database to normalize the data into several tables, to make them some joins, to make them the best and most optimized choice for the fit. Okay, but this is not something that is always the shape that the consumer wants. What I mean? I mean that the consumer can be your colleague that needs to collect that data for a dashboard, a Power BI dashboard, Tableau, ClickView, or anything else to visualize some sort of insights for the company or for the clients, okay? So you just need to join that data to make some other little transformation during the materialization of that rows, and how to do that with the relational database with views. So probably in your experience, you would use some views to make some tables together again with joins, with some filters, with some column names projection. So rename that column into this column name, cast this object type to another type, and so on. Okay, this is the part that I call the data production. So we are producing something for the outside world, for the internal customer, external customer, so for our consumers, data consumers, okay? So this is the typical scenario which I am accustomed with. So let's start from this to design the remaining part of the session. Now, before going into the demonstration and what I want to show to you, I want to highlight some limitation of the relational approach. Okay, think about you are integrating some APIs or a data feed or something that represent a report from outside. Okay, so let's take an analytics platform that can export a report for all the X orders, I don't know, data for the last 1 month, 3 months, 2 months, okay, for a given client, okay. Let's suppose that now, in this exact data, it has like 10 fields. So, I don't know, the ID, the name, the details, the description, the date, the quantity, and so on. And you model the database to fit that 10 fields, okay? If tomorrow the report will start to have an additional field, so the 11th field, okay, with some notes, with some new field that from that part they added because of the feature change, so that could be okay, okay? So you need to come back to this chain and change, or better, improve the engineering part of the tables to let that new field come into the table that you previously created. And this is valid for additional data, so new fields, okay? So with new fields, we can enhance the existing tables. But under the hood, we can also have more issues doing that, because we can have, in real world scenario, we can have indexing on that table. So indexing means the technology to speed up the filters, the wheres, or the inserts, or the joins, because I don't want to dig into that details, but you probably know that in real-world database you have some or many indexes to fine-tune the performance of your database. And when you add some fields or you change the shape of a database table, you will probably need to make some changes even on the indexing strategy, or even recreate the index, include new fields in the index, and so on. So it's not really a seamless operation. It could seem, because you can just think, okay, I'm just adding a new column and that's okay. I just can say add the column nullable, so it's okay with nullable values for the past rows, and the new rows will hold the new values. That could be okay, but with some issues that I just highlighted, okay? It's different if you have an expected entity. So let's say the report. The report can be a collection of rows, but one row is different for any reason, because they fault at their side, so for a mistake, okay, or because we never expected to have that type of row during testing, during during the first phases of the production environment. They even probably never documented that possibility to have a new type of row. And our process, which one? This, the ingestion, would fail because it finds something that cannot fit the database, the table shape we created. So this is another issue that may arise from outside. So we need to rework the cleaning phase again, okay? Or we can have missing fields. So up to now, we take for granted that that column, the name column, okay, should be not null, because it was always filled with a good value, and the documentation said that it's not null. But after all, after a few weeks or days or months or hours, it comes out a report with that name null. Okay, we can be angry with the third party. We can even write an email and call the people to say, you told me that it's not null, and now it's null. Okay, we can do that. But actually, we are not ready to fill the row of the database table without that value, without that value that is null. Okay, so to make a recap, relational is good. In this scenario here, we are creating the database tables, but we may have some issues in case the incoming data may change. Okay, good. So now I'm gonna to introduce the actual example of this session, where we have two datasets, one for movies and one for reviews. I took these datasets from Kaggle, that is an open source community of datasets, and I put all the data inside of that JSON into the relational database to start from the scenario that I'm going to show to you. So, how I got the data? I had the data here. This dataset is composed by two files. One is the reviews file that is quite huge. No, well, it's not huge, it's quite big, it's like 1 gigabyte, and it contains around 500,000 reviews. And another dataset that is movie details, okay? So, just to have a visualization about that, give me a second that I'm opening the movie details here. This is a nice tool to visualize, that right JSON viewer, to visualize huge JSON in seconds. So it is a technology that doesn't block the graphical user interface, even in case of huge data, huge JSON. In this case, the JSON is not so huge because it's 14 megabytes. But in the case of the reviews one, it's like 1 gigabytes for 500,000 items. Okay. And it loaded in 5 seconds. So we can see that the review is the typical review of a movie, while the movie is movie ID, the summary, the plot, the duration, the various genres, the rating, and so on. So few information about the movies and related reviews. Do not investigate into the semantic of this data. You can take this data set as samples, so I don't want to say the real meaning of each field, nothing at all, okay? We are just taking these two data set as an example, okay? And I created the database, which one? This, with some tables, and I already put into that tables those data set in different forms, okay? Now I want to make a parenthesis and introduce a concept that is very familiar for me. That is the database project template in Visual Studio, okay? When you develop, where you are developing databases, it's really good to have something outside from the database that holds all the life cycle management of the database itself, okay? And my best choice is to use database project. They are artifacts that can collect all the database objects. For instance, in this case, I have the movies table represented as a file. Okay, the reviews table represented as a file. I can use the graphical user interface of just editing it with the code. And the good news is that it is buildable. What does it mean? If I build this project, Visual Studio will check all the relationships, foreign keys, data types. So if I made a mistake here in a foreign key and I try to build, it's not just text, but it's compiled. It's not producing something that is runnable, of course. It's just a pseudo compilation that highlights that something is going wrong. So it's a very good approach to make things consistently, and even to put all this stuff into a Git. So to version it, to have some version of the database during time. So my suggested approach is to use something not this isn't the only approach to do that. You can use third-party tools from Redgate, from other companies, commercial solution, but please consider the opportunity to use a technology that can hold the lifecycle management of the database objects. Okay, what I want to highlight to you in this design, okay, in this design I designed the movies table with the movie ID. That's okay, that can be the primary key. Well, it varchar 20. Why? Because I briefly went through the movie details and I saw that could be a good key size. But this is the first consideration that I will show to you. We really know constraints about the incoming data. Probably there's a documentation somewhere telling me that movie ID is always 10 characters. Okay, it's okay. But with this constraint, in case a movie comes out with 21 characters, I would throw an exception, of course. Okay, and the same is for every field that I'm going to build. That's why I used nvarchar max for the fields that are not primary key. And I always say null to consider nullable all the fields except from the primary key. So I can be quite satisfied by this table, but I'm not about the reviews one, because the reviews dataset, here again, it has not key for the single review, okay? It has just a concept of foreign key, so the reference to a movie ID, but itself, the review, it hasn't a key. So to represent this row into a database with a primary key, I needed to introduce the concept of review ID, but it's a surrogate key. It's not real, okay? Something that I need to invent, okay? Also, this row, this line is not making me happy, because I enforced the movie ID relationship with a foreign key to the movies table, but I learned from the dataset, so I went through one by one with the code, of course, into this dataset, and it came out that some reviews had the movie IDs which are not in the movies dataset. So in that case, you could say, okay, if you have not the good relationship with an existing movie, that row can be skipped. Yeah, but if tomorrow the real movie comes down, you lost that review forever. You need to reprocess the data set every time. So this is a real constraint, very specific, very typical for the relational database when we need to achieve the normalization, so the correct relationship between tables, foreign keys, and so on. Okay? And that's enough for this part. Okay. So we saw how to get the data, how to engineer the data. I also show to you to use the database project while engineering the database, because it's better also to perform some sort of edits and all the small fix that you need to apply to the real database. And now let's go to the ingestion part and the production. Well, actually, I skipped in this demonstration all the ingestion part, because you can have best first-class solution to ingest a huge amount of data into your database. For instance, in Azure, we are using Azure Data Factory or Synapse Analytics or the bulk load or something that is not really suitable for a 60 minutes demonstration, okay? So just to leave you some code, to leave you some reference to reproduce all this stuff into your machine, I left the ingestion part into a C# application by using Entity Framework Core. And after that, we are focusing on the production part. So the data preparation is this client code application is a C# application used to import the dataset into different forms, in a relational forms. So I just read the big JSON, and for every item that I parsed, that I strong typed with a real class, I create the database object in Entity Framework Core, and I added it and saved the changes. Okay, it's not my preferred approach. So in a real world solution, I would use the bulk copy. That is really faster, okay, because this is an approach that deals with Entity Framework Core. Entity Framework has the change tracker. It adds a complexity and the overhead due to the classes creation, deploying all the C# objects on top of it. So I don't want anything of this while loading data. I don't want to pass from C#. I'm just I just created this to clarify to you what I did to move that data set into the database, and even to leave to you a sample that you could run into your local machine to recreate the situation and recreate the demonstration. Okay, what is my result? I have this relational table with all the fields in a normalized and strong typed way. So the data types are really fitting and okay. And I also have the same for the reviews. Okay. And now I'm going to make an example of data production. So I create a view from the graphical designer. It's not really needed that I'm coding it right now. I want a view with all the reviews enriched with the movie details. So the denormalized version of the stuff. So I want the movie ID, plot summary, duration, genre, rating, release date, synopsis. Review ID, no, because it's a surrogate key. Review date, movie ID, it's already here, so I don't want to take it from here. User ID, it's okay. Spoiler, review text. Rating has the same name of here, so I'm renaming it to review rating, okay, and review summary. When I have this query, and create view relational dot v reviews, something like that, as that stuff. Created. I'm going to increase the size to make it clearer, and now I have this view that is joining the two tables to produce the result that I want to consume in my application. Okay, good. So now let's come back to this, and let's make our choice. Okay, we can keep the tables, or should go to a different path in what is the promise of the session, so to the JSON path. Okay, I would suggest to keep the tables when you need, for instance, to change individual rows. So for that specific movie, I want to make an update to that row and that rating, okay? Or for that specific review, I want to change that field, to increase that field. So you will see that with the JSON approach, this is very, very difficult to achieve, and even not really performant, okay? In that case, you should keep the tables. So the tables, you will learn that are really useful for transactional data, for that kind of factual data that is going to change a lot of time, a specific lookup of specific rows. But if you have a data set that is quite immutable or immutable at 100%, okay? What I mean with immutable, so the review of a movie, well, it's immutable. You can say no, because a person, a reviewer, can edit that reviews. Yeah, in some circumstances can happen, of course. So the movie is immutable, because the duration of a movie is that duration. It cannot change actually the 99% of time. So when you identify some data set that is immutable or almost immutable, you can store all the data set as a single JSON object, because you don't want to edit just a single field of it in the 99% of the cases. So this is the reasoning that I want to share with you while deciding to keep the relational approach or going to the NoSQL JSON not relational approach, okay? And I also need to mention that you can have both, of course. So you can mix normal plain tables with JSON tables, okay?
Roberta?
Yeah.
So I think one important question before the next demo, I think, should we have a blessing from our DB team for the decision to store a lot of JSON rows in our database? Or could we make something wrong with our database in this
Some
approach?
usage. I didn't get the point of the question. Excuse me, Nikita.
Could we destroy our database through a lot of JSON rows, or it's safe, pretty safe, and we should not worry about that?
Depends of the database engine. So as I got the question, you can think about the database engine that we're using, and it depends really so much from the technology. For instance, I discovered in the last few months that the PostgreSQL has a great support for JSON for even more time than the SQL Server support. And SQL Server support is not really native, so there's no data type that is called JSON as in Postgres. So it depends. For instance, from our experiments and also from the relationship that I did with the product group, I know that you can have a huge number of rows with the JSON, even huge in terms of specific size of that field, and it's okay, because they have a limitation and the underlying technology that permits to have it. But of course, maybe can change from a relational database engine and another relational database engine. I don't know if I replied to your question.
Yeah,
correctly.
Cool. Thank you. Just to warn our audience. Thank you.
To you, Nikita. Well, so we are now at the turning point, and I want to show you the JSON approach. So let's come back to the database. I created and filled with the console application two other tables that are called movie, hybrid, and full JSON. What's that? Let's take top row from the JSON movies hybrid. It's not a standard naming convention, just my convention. I called an hybrid table a table that has some plain fields and a JSON field, okay? While the full JSON, so it's a table that is all JSON, okay? So we have just a key, but actually we can even avoid it because the key is inside here. And in this case of this full JSON table, the single movie item is in this column, and for that movies, all the reviews are in this column as an array, okay? How I did this, I took the two data set with the C# and I split for each movie the appropriate reviews and put into the database as it is. Okay. But now we have the appropriate table that is holding the data, but we want to produce the same result for the end user. So in the plain approach, we just mixed the two tables with a join. Okay, with this approach, we need to make something more. Okay, so let's just take first one, and let's say okay. instead of top one, I'm just focusing on this first movie. Okay, so I'm just filtering where movie ID equals to that ID. Select start. Okay, and I want to project the content of this JSON as columns. So let's start to use the JSON function of SQL Database. So JSON value. The first argument is the column name, movie, and the second is the path to project. Okay, plot summary. Okay, as I would say, plot summary. And I take it out from the JSON document. I can use .write to take this. Those are the reviews, and those are the movies. Okay, we have plot summary, duration, genre, rating, and release date. So let's go faster with some copy paste. Okay, we say duration, genre, rating, duration, genre, rating, release date, and plot. Let's name them correctly. And that's all. Now that we exploded all the fields inside the movie, we can even avoid to project the movie again. So it's not star, but it can be movie ID, all this stuff, and finally reviews. Reviews. Okay. So after that, we need to make the most interesting and nice operation. So to project each of this array element as an individual row. So this single row should become a collection of rows, one for each review, with all the stuff repeated and the specific stuff of the single review. So let's put into a suspended state those values for a while, and let's apply an operation that is called cross apply. That is like the semantic is take that x that I'm going to write and apply that x for each row it applies to. Okay, so what is that x? It's the open JSON of the reviews field. So it's opening this JSON, and for each element of the array, it will create a row in join with a specific row, with a single row. In this case, we are filtering, but it's just for the debugging purposes. After that, we're gonna remove that where, of course. So with this situation, what's the result? Let's have it with the star. That's got the top rows because it's quite heavy. We are going to have this one because I explicitly put it. And with the star, I have again the movie ID, the single movie that I really had before, and in the value field, the single review ID with key 0. So the first review of this array. So now we can have not star, but just value. And now we have like 104 rows, one for each review for this specific movie. What we want to do right now is to project even that stuff with the same approach. So let's do it. Let's take one as a sample. Now it should take the value from the value field, and the fields are review date, and let's see it with the viewer, that it's better. User ID, spoiler, review text. So user ID is spoiler, review text, rating and review summary. Rating and review summary. So let's rename it. This rating should be different, otherwise it would collapse to clash to this one. So I call it review rating, and this is the review summary. And now it's completely normalized. It's completely relationalized. Okay, I'm going to uncomment those lines. And now I have something very similar to that one. Very, very similar. Okay, I have some bugs. Okay, the first bug is that the genre is null. Why? Because in the review, no, in the movies here, genre is a JSON array. So when I tried to say, hey, take the JSON value, it didn't work, okay? Because we need, in case of JSON nodes, to use the JSON query mode. And now it's okay. After that, I really want to cast some columns into the right type. So this release date, it's a text, while here it's a date. You don't see the difference, but I can guarantee that it's really different. The rating here is a decimal, here is a decimal too, but I can assure that is a text even. The spoiler is just the value true in text, while in the good relational form is a bit that stands 0 for false and 1 for true. Okay, so I want to make some sort of a strong typization of those types. Okay, so the genre is okay. The rating can be casted to decimal of 3-1. Why? Because the rating can be from 0 to 10, so 2 digits in the left part and 1 digit after the comma. So this is the right decimal to implement. The release date should be a date, and the date caster automatically tries to fit common formats to the date type, so we can even try, and it's working. This is text, so it's okay. This is another date, so let's cast it again. And this is a bit. Okay, and this is the rating. So last conversion to the decimal. Okay, good. Now it's quite ready, except for that duration. I really want that duration as a time span, so like a time, okay, as in this sample. Okay, where is it? And for this I made a trick. Okay, since it is text, my approach would be to identify the age, keep out the age and the space, put a double a column, keep out the min and replace with a column and 00 that stands for seconds, and try to parse it as a time. To do that, I created a function to be more clearer in the demonstration, because otherwise I had to do this into the same sheet. So the function is cleaning the spaces, the age, the min, and if I try to apply this function to the duration field here, sorry about that, okay, here, I have now a good result. So we are really close to the solution. I'm just removing the filter. I'm just keeping out some spaces. I'm just taking this here and create view JSON reviews as JSON. So view. Okay. So now I have this view that can be consumed by our clients, can be also Entity Framework itself. It will see it as a table. And the good news is that all the fields are exactly compatible with the ones of the relational version, except for the unvarchar for 1000. Okay, but it's a minor issue. You can shrink it, or you can leave it as it is. It doesn't matter. Okay, but the other things like the time, the decimal, the date are really the same, and that is good. This is a good approach. So we used some functions in this demo. The JSON value, so JSON value takes from a JSON node a specific property. We can use it even in the arrays, specifying the index. So $index0 the specific property. But for arrays, we prefer to use the OpenJSON that dynamically applies each item of the array to the same row to produce like the join effect. Okay. We saw the JSON query function that just passes through the specific JSON node into the result, and that was the case of genre, the genre field. We didn't see isJSON, but it's good to mention. IsJSON is a Boolean function that, given an argument, a text as an argument, if the argument is a valid JSON, it returns true or false, and it can be used as a constraint. So what is the value added of this function? If you have a JSON column, you don't have the JSON type, but you have the varchar type, the nvarchar type. So you can say this is a plain old nvarchar type, but check that constraint. So check is JSON of that column stands true. To make the relational database would make a check into the actual data to enforce this is real JSON and not just a text, a normal text. Okay? Good. So now I want to show you some fun. It's not really funny, but it's fun, that kind of experiment. And that experiment was actually a nightmare. So take this table. This table is just an ID and a document. Okay, so I don't take out the document because it's really huge, but I can select ID from playground key value. And this table has just two IDs. I would like to ask to you, guess what's inside that rows. The one row is the entire movies JSON, and the other row is the entire reviews JSON. So one row is holding 1 gigabyte of data, and the other row is holding about 13 megabytes, something really small, okay? How I did this? Because in theory, you can even just have a table that is key value, one key and one value, and link that table to other tables, okay? We use this in production. Of course, this is a real it's a sample just to have some fun. Why? Because the view that represents that data is a nightmare. Okay, let's take a look to the view. The view says, take the element 4, that is the collection of reviews, open JSON, so cross-apply, parse all the stuff, and join that review with the movies that you find in document 3. this is a join. Instead of a join, there's the condition that performs a join. Okay. The result is the same interesting schema, but in terms of performance is really awful. Okay. I try to take the first 10, but I think it would think about a minute or a couple of minutes. Why? Because to do that, to do the cross apply and the join, it would perform an operation that is called, in this case, the tables pool. So it takes all the row in memory to make this operation. So in this case, it's not really well optimized, but this is it's provocatory. Okay, I just want to tell you that you can have actually a key value table for your purposes, and it's working. Of course, you just need to keep to pay attention to the size, the dimension of that data. But this is an operation that this join operation is really huge. If you just want to take the first item of the reviews document, it would take around a second or even less. So this is slow for the complex operation it needs to perform. So that was an experiment, fun, but just to highlight that you can have a key value store into your relational database. Good. So now we made, so let's start from the beginning. Let's recap a brief. We introduce the relational database approach. We try to implement a Json approach, and now I want to give you some insights, some takeaways for what's next. Okay. For instance, you use this approach and you discover after 2 or 3 months that that JSON documents are old. Nobody uses them anymore. They are not really useful, okay? So you are just reasoning, is really correct that I'm keeping all that stuff in a JSON form, which is which the size is really huge because it's text actually, while I can make some history tables of some shapes in another form? The actual answer is yes. So after you see that your data is not changing anymore, on the JSON is too big, or you need to make historical tables of that reports of that data, and you do not need anymore that kind of flexibility to build the view in a good way. So you can go ahead and make some history tables, okay? So what I want to do as the last demonstration is the denormalization of this stuff. So we have our view here, okay? So this is the view that takes from the JSON tables, okay? I want to create with the stop even 10,000 star. I want to put those first 10,000 rows into a new table that is called test heap. I will tell you why it's called heap, and let's run it. It would take 10 seconds, something like that. Okay, good. Now we have a new table that is called test heap with this schema. This is a real table, okay? It's not a JSON table. And now we have here all the stuff in a relational, in a frozen form. So if I change the specific JSON into the original table, this one, of course, this is a new table that is completely disconnected from the dataset. So what I want to tell you, that in case you want to keep out some rows, some JSON rows from the database because they are huge and they are not useful anymore, you can use something like the select into or insert into select to a historical table all the result you want. I just limit the first 10,000 to be efficient in this demo, but I could also say select star from the v-reviews and put all the result into this heap. Why it's called a heap? Because it has not a clustered index. I don't want to go too much in the details of SQL Server, but the clustered index is the index that comes out in the same physical structure, in the same logical structure of the database. So we can have two types of clustered index. One is a row index based on a number of fields, and one can be something that is called column store index. Okay, why I'm telling you this? Because from the sides point, the point of view, these tables are in this situation. So this heap for just 10,000 rows has a size of like 70 megabytes. Okay. So the complete one, this was the test, the dry run that I performed before, it's like 3 gigabytes. Okay. There's a technology in SQL Server, as in many BI solutions like Tableau, Power BI, and like that, to compress that a table in a columnar store, okay, in a columnar format. And in SQL Server, it's called clustered column store. So I can say create clustered column store index. I can use this on video data. And after that, the size is like 80% less than the original size. So this is a recommended approach if you want to save space from in your journey. So you need to to be fast while collecting the initial data. So go with JSON and go with the views to have the appropriate shape of your data. After that, when you are quite stable, you can use that views. And after that, when you want to make historical tables, put the results into a heap tables and convert it into a clustered column store tables. In this approach, you won't just be smaller in terms of size, but you also gain some sort of interesting things around analytics. Why? Because the column store tables are really fast for aggregate operations. So if you want an average of the rating of the whole table, this will take a millisecond because it's just evaluating the column and not the others. Okay? Good. So, as takeaways, I would say that relational is really good, but JSON can really enhance your productivity and make you faster. This is the point that I want to highlight. In fact, the good way to see this demonstration in I want to be faster, I want a shorter time to market, but after that, I can even denormalize of the stuff and make historical tables with some indexes, with some other stuff, of course. I also heard, and I hope it's true, that with the upcoming release of Entity Framework 6 in November, we will have native JSON support in our tables. As you can see, with the Postgre implementation of the actual Entity Framework 5, we can already have this. So we can have a JSON column that is mapped to a specific type, and the Entity Framework provider will deserialize it during the materialization. So this is a great approach, and we can even use this in a query because PostgreSQL use really good the JSON formats inside the database. We are hearing from we have rumors and actual documentation on the Microsoft websites that the JSON support will be introduced, and we will probably have this kind of API also for SQL Server. So we already have some spots during the session, but I don't want to add anything else to what I said. Just try the JSON approach. The relational is really good, but try to integrate them. And you can always put your data into historical tables. You don't have to be to do this initially, and you don't have to do this at all. You can just do this if you want and if you need. And that's all. I thank you very much, and I'm here for your questions.
Oh, thank you, Roberto. Perfect and useful presentation. Actually, I have a lot of questions. We have some questions in the chat, but unfortunately, time is over as for now. Dear audience, I would suggest to continue in the discussion zone in just 1 minute. We'll reconnect into the discussion zone. And thank you, Roberta. Thank you, audience, for watching. Thank you, Roberta, again.
Thank you, Nikita, and thank you all the attendees. I'm here in the room for 1 hour for your questions. So catch up in a minute.
Yep. Thank you.
See you.
Bye.